Okay, I just started. Yeah, so we have the poll results. We have respiratory and cardiovascular diseases as the top ranking options.
Yeah, I think that follows a lot with what are sort of like the main health outcomes that we sort of hear about most in the news, but also those that are sort of a primary impact, especially for like individuals with cardiovascular problems or with respiratory problems as well. So thanks for responding to that. Moving to our intro. So I'll start with some background information, providing context to our research question. And as this group seems to be aware, air pollution is associated with a number of adverse health outcomes, including respiratory and cardiovascular diseases. And there's also a growing body of evidence for a link with neurological disorders through cognitive function, stroke, and also dementia. But the exact mechanisms by which air pollution mediates these impacts are largely unknown, with suggested mechanisms including vascular and inflammatory mechanisms. And these might have harmful impacts on the brain and other cognitive processes, similar to the way that increased macrophages and lung impact lungs as well. And this brain injury could be a secondary impact to systematic inflammation in response to air pollution. So in prior studies, neurological impacts have been observed in children and also adults, observed through developmental delays in vocab, visual, memory, and attention skills, but also through accelerated cognitive impairment in older adults. There's been mixed observations, and a lot of that has been attributed to different populations being assessed, different exposure definitions. So in this bubble, air pollution has been defined as a number of things, from PM to certain components to ozone, but also to sort of metrics of distance from roads to quantify a certain exposure. And these observations have been made worldwide, with negative associations being the primary observation. However, most studies have focused on smaller populations in individual cities, and there's a need for larger studies. So the second question I have was, have you guys used Lumosity before? To kind of get a gauge on your background before jumping right into this.
Okay, just launched.
Thanks, Angela.
You're welcome. Okay. Let's just give it a couple more seconds. Okay, I think we're good.
Yeah.
Results. Okay, so I guess the most people haven't heard of it, have heard of it, and yeah, very few people have actually used it before.
Yeah, so that's interesting. Awesome. Thank you guys for responding. So for our project AIM, this study is the first to look at neurological impacts in a larger US-wide population, including individuals 18 to 90 years old. And our aim was really to examine associations between long-term air pollution, in the study specifically looking at PM2.5 and ozone, and gaming tasks for this app. And exposure was estimated at a ZIP3 level, which is the level that we got the game data from. And our cognitive data comes from Lumosity games. And this is an assessment of cognitive function through one of their specific games, the Loss and Migration game. And this game reflects selective attention, specifically like the ability to focus and filter information and avoid distracting information. And their gaming tasks are built based on cognitive psychology. And this data set offers a large scale opportunity for investigations of human learning. So overall, we have a longitudinal retrospective analysis of just over 29,000 users, and where each individual in this case is going to contribute 20 gameplays. And with respect to this project, we hypothesized that we'd see air pollution related reduction in cognitive performance observed through this reduction in the learning curve. So we defined long-term exposure based off of population weighting, PM2.5 and ozone from the federal reference method monitors using 365-day rolling averages. So looking at the 365 days prior to a specific gameplay. In our models, we looked at the additive effect of PM2.5 and ozone measured using linear model with random effects. And this just means that we controlled for area level confounders, with our outcome being the change in the score percentile and focusing on additive effect of PM and ozone in co-pollutant models. We were able to control for the age device specific learning curve and also meteorology as temperature and relative humidity are important to PM and ozone as well.
No problem.
In addition, we also controlled for the time trend, user age, and other user-generated info and area level confounders, such as socioeconomic status from the census. So the analysis focus, our primary analysis, we focus on age stratification, focusing on these decade ranges. As generally we expect age-related differences in cognitive performance, but here we're asking the question, does air pollution modify that association? And in secondary analysis, we're looking at impacts on the learning curve, looking at 4 specific learning stages, which have been used before with Lumosity data. So asking the question, would there be air pollution related differences based off of early learning versus later learning? So this map shows the location of the Lumosity users based on the density, the number of individuals by zip 3 area. And the main takeaway is that most users of this app reside in very high population areas. So in this table, I'm going to go through a breakdown of the demographic summary of what individuals were captured in the study, and also showing the breakdown by age group, since that was our primary analysis focus. So the mean age was around 51 years. We had more females, though this did differ by age group, with older users tending to be more female. In terms of education, we also observed differences where increased percentage of high school was observed in the 18 to 29 age group, with slightly more percentages towards bachelor's degree or higher education with older age groups. In terms of score, the first score, but also scores in any representative stage in general were higher for the youngest age group and decreased steadily towards the oldest age group. And lastly, like the map indicated, the majority, over 93% of all users in any age group are predominantly reside in a metropolitan area. We also observed by age groups that the average PM and ozone were similar. So we didn't expect to see PM or ozone related driven differences that might bias if there were differences by age group on their estimated exposure. And it's also good to note that these exposures from our predictions are lower than US EPA national air quality standards, with the PM 2.5 annual mean being 12, and most of our means being less than 9, and all of these also being less than 0.07 for ozone. So for the first results, they're going to show the effect estimates for the full analysis and also for the co-pollutant models stratified by age group. And all these models will already be adjusted for the factors we mentioned previously. And the effect estimates on the y-axis will show the reflected change in the score percentile. So on the left, we have the change in effective PM per change of 1 microgram per meter cubed. And we see that overall for that population, we observe a 0.1% reduction in percentile. In our models that were stratified by age, we see that most of this seems to be more attributed to the 18 to 29-year-old group that has a 0.3 reduction in that score percentile. with the 30s group slightly trending towards a positive association. On the right, I'll be showing the ozone results for 0.01 ppm. So in the main model with all ages, we didn't observe a significant difference related to game score. However, when we stratified by age, we observed a similar trend of much greater impacts, nearly 3% in the two youngest age groups, and a significant positive trend in the older age group as well. And the positive association in the oldest adults was somewhat unexpected, but we hypothesized that this might be related to behavior, as there's advisories for these individuals to stay indoors during heat events, and that might potentially reduce their ozone exposure. So secondarily, I'm going to show the results from potential modification by game stage. So does age modify the association with respect to the different parts of this learning curve? So in this same sort of schematic, in the unstratified model, we did see slightly greater PM effect with negative learning in the first and the last game stage 1 and 4. When we broke that down by age groups, we see that this was largely that the early deficit might be more attributed to the 18 to 29-year-old group, which predominantly most of their scores were significant and negative, while the oldest age groups, 60 to 90, they had a large reduction with respect to their last game stage. While sort of the middle ages, we sort of didn't see evidence of a large trend. With ozone, showing these results also by game stage. In the main model, we didn't see evidence of differences by game stage. However, when we looked at them by age groups, we did see some trend in terms of, in the youngest group, there was a trend of greater score reduction at later game stages, though these confidence intervals are very overlapping for the 4 stages. And for the rest of the 4 groups, there was no real change based on game stage. So the strengths of this study really include that we're looking at a nationwide population, including a large range of both younger and older adults. It's a large-scale data set, which allows for a more extensive investigation. And the longitudinal design gives it a lot of power in terms of looking at associations. And these game tests also have been priorly used in other studies as they represent cognitive psychology. The study does have some limitations, including the potential for exposure misclassification. The ZIP3 area is a large area, though it's the resolution that the smallest resolution we had for this study. But this area could also represent a number of places, either an individual's home, school, or other location, as this location was based off of their first interaction when they registered with Lumosity. So it might be unlikely that people could move from wherever they registered throughout the day when they're playing. Potentially, there's also unidentified user behaviors that we're unable to adjust for, potential learner characteristics, or also participation for why people might be interested in using an app like this. And so related to that, the generalizable, our results are really generalized to app users. So in summary, we really observed that the age was an important modifier of both PM and ozone associations with focus score, and that the modification of game stage, going back in the youngest group with PM, that resulted in about a 0.3 reduction in focus score percentile, with a larger result observed with ozone with almost a 3% decrease in this focus score percentile. We also saw trends with game stage of potentially greater effects at later stages for older adults, but that this also should be followed up in future studies. And overall, our work highlights the potential of PM and also ozone associated cognitive deficits in young adults, and this could lead to impacts in daily functioning. So with that, I'd like to acknowledge other collaborators on our project, including Stephanie, who will be presenting next. Thank you.
Okay, Stephanie?
It looks like I'm unable to share my screen.
Oh, okay. Can you try it now?
Yeah, that works. Thank you.
Thank you.
So piggybacking off of what Lauren just presented, I'm going to be presenting our work on investigating the impacts of short-term exposure to air pollution on cognitive performance, which is adjacent to looking into the effects of long-term exposure. So first, we're going to have a quick poll. So given that, as Lauren showed in her presentation, that long-term exposure to air pollution impacts cognitive performance in adults, especially young adults, do you think that there's going to be an effect of daily and or sub-daily exposure?
Just launched. Okay, let's give folks a few more seconds. Okay. So the majority, both daily and sub-daily.
Interesting. Well, you'll find out in a second if you're correct or not. So getting into the background for this research, the reason we wanted to look into short-term exposure in addition to long-term exposure is for this, we're instead of looking into PM2.5 and ozone, we're looking into PM2.5 and wildfire smoke specifically, which are both pollutants of growing public health concern. And while there's mounting evidence for the cognitive effects of air pollution, the majority of research, as Lauren mentioned, has been focused on long-term exposure and specifically the effects in adolescents and in older adults. And right now there's very limited evidence on the impacts of short-term exposure, and the limited research that has looked into exposure to daily PM2.5 specifically has found worse performance on cognitive tests, but there's very little evidence on the effects of sub-daily, so hourly PM2.5 exposure. There's little to no evidence on the effects of smoke exposure, and there's little to no evidence on the short-term effects of short-term exposure in the working age population. So not children and the elderly, but also people aged 18 to 70. So the goal of this work was to overall evaluate the impact of short-term PM2.5 and wildfire smoke exposure on cognitive performance in US adults. And that broke down into kind of two specific goals. So for PM2.5, we're looking at the effect of daily and hourly exposure to PM2.5 in the Western and the contiguous US. And then for wildfire smoke, we're looking at the effects of daily and weekly exposure to smoke in specifically just the Western US. And we limited the analysis of wildfire smoke to the Western US because that's the region in the US that experiences the most direct impacts of wildfires. And we decided to analyze the effects of PM2.5 in both the Western and contiguous to see if the effects varied in wildfire impacted regions. So as this is very similar to the data that Lauren used, we're using, again, Lumosity, which is the brain training platform, and data from the loss and migration game, which targets selective attention. And similar to Lauren's analysis, we have 20 repeat measures per user. The users are aged 18 up, and this data is available at the ZIP3 level. And for this analysis, we had data from over 10,000 contiguous US users and then 1,800 Western US users. The exposure data we're looking at for PM2.5, we use daily and hourly average observations from US EPA and Purple Air monitors, so both kind of high cost and low cost monitoring networks. And then we did a data fusion of these observations in order to estimate daily and hourly average PM2.5 at census tract population centers. And then we population weight those estimates to the ZIP3 level to match them to the resolution of the Lumosity data. So this figure on the right here is showing what it looks like before we population weight it. And then the bottom is what it looks like once we population weight it to that ZIP3 level. For smoke exposure, we're using smoke density data from NOAA's hazard mapping system, smoke and fire product. And what this provides is it provides shapes of smoke plumes with the different densities, and densities can be classified as light, medium, or heavy. And again, in order to match the resolution of the Lumosity data, we take the maximum daily smoke density observed in a ZIP3 as that day's exposure. And we're unable to do sub-daily analysis using the smoke data since it's reliant on satellite overpass time. So the statistical analyses we did in order to evaluate the association between cognitive performance and these measures of smoke and PM2.5 is we use a longitudinal repeated measures design with a linear mixed effects models. And again, for PM2.5, we looked at this in both the Western and contiguous US. The outcome was the Lumosity score, and then the exposures we considered were 7 lags of daily average PM2.5, and then also the max hourly average PM2.5 in the 3 and 12 hours prior to play. So we're looking at both daily and sub-daily exposure. For smoke density, we again only looked at the Western US. The outcome was also the Lumosity score. And for the exposures, we looked at the maximum daily smoke density, the day of gameplay and the day prior to gameplay, and also in the 1 and 2 weeks prior to play. So we're looking at the daily and weekly level for smoke exposure. And we adjusted for a number of covariates. So time covariate, the time of day, days since last play. We also have different meteorological variables, such as the relative humidity and temperature. We also control for different user-specific things like age group, gender, education, et cetera. And then ZIP3 level characteristics, such as the high school graduation rate, the poverty, and the rural-urban continuum code. So how metropolitan a certain area is. And we also control for the learning. So this plot to the right is showing on average how users improve their score over their 20 plays. And you can see it follows this general curve where they do improve each play. So the model also controls for that improvement in learning. In addition to looking at this overall for the entire study population, we also looked at this by age group and by gender to see if there's any specific or specifically vulnerable subpopulations. So getting into the results for these, the first thing we saw with PM2.5 is we observed significant negative associations for both sub-daily and daily exposures, and that this association is more pronounced in the Western United States. So here you see we have the 3-hour max, the 12-hour max exposure, the day of play, and the 7-day cumulative effect. And there's significant decreases in score per 10 microgram per meter cubed increase in PM2.5 for all of these exposures. And again, that effect is more notably pronounced in the Western United States. Digging into this by age, the results I'm showing here are going to be focused on the Western US because again, we're seeing the more pronounced effects there, but the contiguous US results mirror these results almost identically. They're just slightly more attenuated. But looking at these results by age, we see that the youngest and the oldest users are most affected. So the 18 to 29, while not significant, is quite negative. And additionally, if you look at the 70 plus and even the 50 to 59 and 60 to 69, we're seeing this more significant negative effect in these younger and older users. When we look at this by gender, we don't really see any observable differences by gender. So across the board, male and female players appear to be similarly affected by both subdaily and daily PM2.5 exposure. Getting into the smoke results, again, there can be light, medium, or heavy smoke density. And what we're seeing here is both medium and heavy smoke density are associated with decreases in score relative to no smoke. And specifically for medium smoke density, it's significant at lag 0, so the day of gameplay. So medium smoke density is the day of gameplay, and then in the 2 weeks prior to play had significant associations. And for heavy smoke density, the presence of that the day prior to gameplay and in the 1 week prior to play were significantly associated with decreases in score. And what this is telling us is that both medium and heavy smoke density at the daily and weekly level impact cognitive performance. And so it has both an immediate and apparently a lagged effect on users' performance in Lumosity. When we look at this by age, this is a lot to depict, but what we're seeing here in general is there's no effect of light smoke density, but for medium and heavy, users age 18 to 29 and 40 to 49 appear to be most affected. And we especially see this in the heavy smoke density category. So again, similar to the PM2.5 results, that youngest age group is seeing, while not significant, seeing some of the more negative impacts of exposure on their performance in Lumosity. dissimilar to the PM2.5 results. What we're seeing when we look by gender is that we see that men are more affected by smoke exposure, specifically heavy smoke density, than women are. So if we see, if you look at the heavy density for lag 1 week, and 2 week, you see a more significant impact in men compared to women. So men appear to be more vulnerable to the effects of smoke exposure in terms of their performance on lumosity. The general strengths and limitations. So one of the biggest strengths of this study is, again, as I mentioned, the short-term results are not as well investigated. So this is actually the first study to look at the cognitive effects of short-term PM2.5 and smoke exposure in a large working age population. So that's a large strength in Lumosity. By giving us repeat measures for over 10,000 diverse users, it gives us the ability to kind of really dig into both the effects of daily and subdaily exposure and identify the more vulnerable populations. And another strength of the study was using the data fusion to estimate the PM2.5 concentrations. And this is beneficial because not only are we using more information, so we're using data from 2 different monitoring networks, both Purple Air and EPA, but it also ensures that we have exposure data on every day and every hour for the entire study period for all of our users, which means we're not losing any data to not having exposure data. With that, there's obviously some limitations with the study. First and foremost, while Lumosity has been used in a lot of prior studies and has been shown to improve cognitive performance in more clinical measures, it itself is not a clinical measure of cognitive performance. So while we're seeing these significant decreases in Lumosity performance, we don't exactly know how that corresponds to performance in real life tasks. Again, this is similar to Lauren. As Lauren mentioned, there's also the possibility of exposure misclassification. We're looking at exposure at the ZIP3 level, and first, especially when you're looking at wildfire smoke, those concentrations can change rapidly over short distances. So looking at the ZIP3 level, we probably lose some of that detail with the exposure to smoke. So there is the possibility of exposure misclassification. And again, we assume the user remains in the same ZIP3 for all of their plays. And so we're not able to account for if they've moved location when they've played different things or played different games throughout their 20 games. Additionally, we're also unable to control for all individual user characteristics. This includes user behaviors, as well as other user information. And then, as Lauren mentioned, the generalizability of these findings may be limited to other Lumosity users or adults of similar characteristics to our study population who are also using brain training applications. With that, in summary, what we found is that short-term exposure to both PM2.5 and wildfire smoke adversely impact attention in adults as measured by Lumosity performance. And for short-term PM2.5, this is both at the daily and subdaily level. And for wildfire smoke, this is at both the daily and weekly level. So we're kind of seeing it across a large spectrum of short-term exposure. We're seeing these adverse impacts. Additionally, another notable finding was that the PM2.5 effects were more pronounced in the Western US. And we hypothesized that this might be due to regional differences in composition. So since wildfires are a large source of PM2.5 in the Western US, the composition of that particulate matter is different, which can affect toxicity and may in turn affect the impact. There's also the possibility of other wildfire related impacts playing a role, such as wildfires increasing stress and anxiety, which may also increase cognitive performance. So there's a variety of reasons that we're hypothesizing why the PM2.5 effects might be more pronounced in the Western US. Additionally, we found that younger, older, and male users were most vulnerable. So younger users, that was for both PM2.5 and smoke. Older users were particularly impacted by PM2.5 and male users by smoke exposure. So we're able to identify these more vulnerable populations. And we think some important future work includes analyses of cognitive domain beyond attention. So again, this is using the data from one single game targeting improvements in selective attention. And so while we're seeing these significant associations between decreases in attention score and exposure, it would be valuable to look at other cognitive domains, such as memory or other things. And with that, we're going to have one more question. So given evidence that both long and short-term exposure to air pollution adversely impact cognitive performance, as Lauren and I presented today, are you more likely to change your behavior on poor air quality days to reduce your exposure?
Okay, launched and okay, let's send it here.
Okay. So it looks like most of you, either yes or depends on how bad the air quality is, would consider changing your behavior, which is great to hear, because you do want to protect your cognitive performance in your brain. And with that, Lauren and I are happy to take any questions people might have about either of our work.
Great, thank you, Stephanie and Lauren. So now we will have our students' questions.